Good afternoon. My name is Christopher Corbin. I'm a program manager with the United Nations Environment Program, Cartegena Convention Secretariat, based in Kingston, Jamaica. And I'd like to begin by thanking the organizers for accepting our abstract and also allowing us to present at the 12th National Water Quality Monitoring Conference and to share our experiences in the development of a collaborative assessment of marine pollution from land-based sources and activities in the wider Caribbean region. Why say a collaborative effort? We could not have done this alone. This report was supported with financial contributions from two projects funded by the Global Environmental Facility, the Caribbean Large Marine Ecosystem Plus project, and the Integrating Water, Land, and Ecosystems Management project. We benefited from having expertise from throughout the region, from several regional technical agencies, experts, country experts, two lead authors, and the coordinating support provided by a technical monitoring and assessment group chaired by our focal point for land-based sources of marine pollution from the US EPA. And I want to acknowledge the significant role that all of these persons and agencies played in the finalization of the report. Why is this report so important? And the billions of dollars speak for themselves. The Caribbean Sea is essential to economies of countries of the wider Caribbean region, whether it be for shipping, maritime transport, tourism, fisheries. The values are in the billions of dollars. And all of these are under threat from marine pollution. And in addition to the economic sectors, we have the estimates caused to diseases. Diseases caused by pollution of coastal waters due particularly to sewage are also thought to cost billions of US dollars annually. What are we looking at in the Caribbean and in the wider Caribbean region? No different from many other countries, multiple sources of pollution from various land-based activities, including grey water, stormwater runoff, untreated domestic wastewater and sewage, garbage, plastics coming down our gullies and rivers, sedimentation, including from mining and industry, and agrochemical runoff of fertilizers and pesticides, resulting in significant coastal and marine biodiversity impacts from harmful algal blooms, fauna mortality, coral bleaching, and declines in seagrass resources. But perhaps even more importantly, impacting on economic sectors of fisheries, of tourism, and on human health. What is the framework that we use for the development of this report? And it was the Cartegena Convention, the only regionally legally binding agreement for the protection and development of the Caribbean Sea. 28 member countries throughout the wider Caribbean region working collectively to sustainably manage the use of our critical resources and to control, reduce, and prevent marine pollution, while also achieving other regional and global commitments such as the Sustainable Development Goals. And this visually represents the countries who have both ratified our Cartegena Convention. As you will see, only 2 have not yet ratified, and there's 15 countries who've ratified our protocol on land-based sources of marine pollution. Work in progress, I say, as we work to have all of the countries of the region sign on to this very important legal agreement. Why is the convention and why is the protocol so important, and how has that formed the basis for this report? Significantly, one of the objectives being to exchange scientific and technical information on land-based pollution through regional cooperation and monitoring and research. And this report represents that type of cooperation. But more specifically, in a region that's strapped for financial and technical resources, the importance of identifying and assessing the sources and activities contributing to pollution, so that with the limited resources that we do have available, we can get the greatest bang for the buck by focusing on those activities that are contributing the greatest pollution or having the greatest negative impact. The journey has been a long one, starting as early as 1994, when the Secretariat produced its first regional overview of land-based sources of pollution using estimated pollutant loadings, referred to as the SEP Technical Report 33. In 1999, we had the formal adoption of the Land-Based Sources of Marine Pollution Protocol. In 2010, we updated the SEP Technical Report 33, named it SEP Technical Report 52, but again, focused primarily on agrochemical loadings from agriculture and industry, and significantly dependent on modeling studies. In 2010, the Protocol on Land-Based Sources of Marine Pollution entered into force or became legally binding. And in 2019, perhaps one of the more comprehensive reports on marine pollution developed by the World Bank with contributions by our Secretariat, but focused mainly on descriptive and not very much on country verified data. And this is where our report in 2020, State of Convention Area Report on Marine Pollution, was so different in being based on national data. And I want to emphasize that because this is really the first regional assessment of the state of marine pollution based on this national data, and represents more than 5 years of research, of analysis, of data review, and of country verification. A significant part of the methodology was the identification of what would be the most important pollution indicators that we could monitor based on national monitoring programs that were in place. And indicators were developed to cover aspects relating to eutrophication, chlorophyll A, to nutrients, dissolved inorganic nitrogen and dissolved inorganic phosphorus, hypoxia, looking at dissolved oxygen, acidification, looking at pH, turbidity to monitor sediments, and we had fecal coliforms and enterococci to help establish the sources of fecal contamination. Also importantly, the methodology for the first time for us employed the full driver pressure state impact response framework that looked at not just the end of pipe or the status, but what were the drivers, what were the economic drivers, what were the major pressures, what was the quality of the environment, what impacts were we seeing on coastal and marine biodiversity and human health, and what responses were being done by governments, whether or not it be policy responses or technological solutions. Important part of this process was the data collection and analysis. And again, to emphasize that this was an extremely difficult process for a few reasons. Despite the efforts, data availability and access throughout the region is challenging. In some cases, the data just does not exist. There are lack of national monitoring programs. Many of these monitoring programs are project focused, so we don't have data, for example, covering both the wet and the dry season. For some countries, there was sensitivity, particularly about water quality, that could have potential impacts on the tourism sector. There was also the concern about how are we going to display this data, and a significant amount of discussion took place in terms of how best were we going to classify information, for example, looking at good, fair, and poor conditions. When we had data that was lacking for some countries, how could we utilize modeling to help fill those gaps? But importantly, the data was fully endorsed and reviewed and verified by government focal points. We had several regional and in some cases global experts who provided guidance and advice. And by having the report reviewed through our own intergovernmental processes and meetings of contracting parties meant that there was full ownership of the report by the countries. And this is what I call the work in progress. Some really good data from many countries, including the United States, but some ways to go in ensuring that we have all of the governments being able to contribute in the future. So what did we find? Not so good. The indicators showed a high proportion of sites with poor status across all the subregions of the wider Caribbean region, with the possible exceptions of dissolved oxygen and pH. For the most part, the indicators showed a higher level in the wet season, and the hypothesis is that this is due to the greater amount of runoff and discharge from land. fecal contamination throughout the coastal waters of the Caribbean Sea, as evidenced by levels of Enterococcus and E. coli, were widespread and in some cases high. And the hotspots tended to be more localized, but around areas of major discharge, for example, rivers, gullies, sewer outfalls. One could argue that wastewater, the discharge of untreated sewage or partially treated sewage, remains a significant concern. It's estimated that as much as 15,000 cubic kilometers of domestic wastewater continues to enter the Caribbean Sea untreated, representing somewhere between 60 and 70%. And this needs to be a major focus of our interventions moving forward. We try to capture the data in as visual a way as possible, and this just gives you an idea. For example, the chlorophyll A concentrations, quite a number of greens and yellows, which represent the good or the fair to good range. But when we look at Enterococcus or we look at nutrient discharges, a lot more in the red range, representing poor. And these are the sorts of visual depictions that would assist us in communicating the message to our decision makers. And if we looked at the entire region, I mentioned that we grouped it into different subregions. The subregions with the greatest input of nutrients, in particular dissolved inorganic nitrogen and dissolved inorganic phosphorus, were also associated with the major river basins. Perhaps no surprise. The Mississippi into the Gulf of Mexico, the Orinoco River Basin in Venezuela, the Magdalena River Basin in Colombia. And I want to highlight that although in terms of total quantity, the smaller islands seem almost negligible, again, we have to look at the context. And in some cases, in a small island with a high dependence on fisheries and tourism, and maybe an offshore coral reef, these could even be significant, even if not in the same loading scale as some of the larger regions. And then we look at the emerging issues, the other threats. Plastic waste, perhaps no longer an emerging issue, with 1.3 million tons of plastics discharged in the Caribbean Sea, estimated in 2015. And the estimate also through modeling that the Caribbean Sea has one of the highest floating plastic concentrations in the world. There needs to be action on this. And in terms of mercury, another emerging issue, we found the work shared by our Caribbean Regional Center for the Basel Convention showed high concentrations of mercury in human hair samples. Again, the need to address an issue such as illegal mining, which is contributing a significant amount of mercury waste. So we have a long way to go as a region to attain our sustainable development goals and targets relating to pollution, particularly goal 6 on water and sanitation and goal 14 on oceans. And this is critically important for the Caribbean and for the wider Caribbean region, who are advocating the importance of taking a blue economy approach, depending more heavily on ocean-based economies. So apart from tourism, fishing, and aquaculture, which have the potential for growth, if we are going to embrace ocean-based economies, we have to address the issue of marine pollution. And this means we need to focus on national implementation. We need to expand regional cooperation through looking at existing regional strategies and platforms. And even for an effort like the SOCA on marine pollution, our belief is that we have to look more now at more integrated environmental assessments that look at the drivers of pollution, the loads, the impacts, and how are we responding, so the approaches can really be harmonized at a regional level. What does that mean in real terms? It means adopting these integrated approaches, ecosystem-based management, marine spatial planning, integrated watershed and coastal zone management, so that we really bring together the issues of land use and of development and have it be part of the development agenda. And we need to change the narrative. We need to consider the circular economy, the nature-based solutions, water as a resource, sustainable agriculture, and innovative financing for sustainability. So what do we still need? We need education and awareness. We need to replicate and upscale what's working. We need to focus less on the end-of-pipe treatment, pollution prevention at source, development of national action plans to address pollution. We need to continue to build a monitoring capacity and quantify the economic impacts of pollution. The regulations and policy responses are weak, and we continue to need the support in reforming these at a national level. We need the partnerships with academia, with private sector, with citizen science, and we need the focus on training and technology evaluation. On that note, I'd like to thank you the presenters. I've included a number of reference links, so I'm happy to take any questions that persons might have. Thank you so much.